Hello my dear student, welcome to video number 138 of the channel MALACHEMPHILIC, and this video is the 77th episode of Chemical Thermodynamics where the topic is Thermochemistry and this is the third part. First and second part already we have finished and now this is third part. Let's see what is there. So, already I told you in thermochemistry we are going to discuss these topics like enthalpy of reaction, enthalpy of formation, enthalpy of combustion, enthalpy of transition, enthalpy of phase change, enthalpy of neutralization, enthalpy of solution, bond enthalpy, Hess's law and Born-Haber cycle. So already I have discussed this enthalpy of reaction and today I am going to discuss this enthalpy of formation and enthalpy of combustion. So let's see. So what is enthalpy of formation or heat of formation? This is also called heat of formation. 1 minute. So heat of formation or enthalpy of formation is the amount of heat absorbed or released when one mole of the compound is formed from its constituent elements in their naturally occurring state, and it is denoted by this delta HF. Now another term, standard enthalpy of formation. This is enthalpy of formation at the standard state. Standard state means already I discussed, that is 1 atmosphere pressure and mostly 298 Kelvin temperature. So standard enthalpy of formation is the amount of heat absorbed or released when 1 mole of the compound is formed from the constituent elements in the naturally occurring state at 1 atmosphere pressure or standard condition. Now, for exothermic reaction, exothermic means where heat is released. Okay. So, for exothermic reaction, delta HF, this is negative. Heat is released. Negative means as heat is released, amount of energy is less, so compound form is more stable. So what is the conclusion? Conclusion is compound formed is more stable. Okay. Now, for endothermic reaction, what is that? Delta HF, this will be positive. That means energy is absorbed. More energy means less stability because energy is inversely proportional to stability. So, compound formed is, I'll write like this, compound formed is less stable. Okay. Now, another thing I want to tell you here, that is this standard enthalpy of formation of the element in their naturally occurring state is 0. So what I told you, that standard enthalpy of formation of elements in their naturally occurring state is equal to 0. What does it mean? Delta HF naught, that is standard of say chlorine gas, because in the natural state chlorine is gas, that is 0. Again, delta HF 0, that is standard. Carbon in the graphite state, okay, that is the naturally occurring state, that is equal to 0. But if you write delta HF naught, standard enthalpy of formation of bromine gas, that is not is equal to 0, because in case of bromine, naturally occurring state is liquid. Okay. Now, coming to this problem, the heat of the reaction of this reaction, carbon plus oxygen, carbon dioxide, that is minus 400 kilojoule at 25 degrees centigrade and 1 atmosphere pressure, that is the standard state. Calculate heat of formation of carbon dioxide. So we know that this heat of the reaction, delta H reaction, already in my earlier video I discussed, that is the enthalpy of the product, summation of the enthalpy of the product minus enthalpy of the reactant. Okay. So here this delta H reaction, which is equal to minus 400 kilojoule, that is equal to what? Enthalpy of product. That means here it is enthalpy of formation of carbon dioxide. Okay, enthalpy of formation of, this is standard. For this is 0 means standard state, because 25 degrees centigrade, 1 atmosphere pressure. Formation of carbon dioxide minus enthalpy of formation of this what? Carbon solid state plus enthalpy of formation of this oxygen gas, this one. Okay. So what we can write? Minus 400, that is equal to your delta HF naught, that is enthalpy of formation of carbon dioxide, minus, this is the elements in the naturally occurring state. So this enthalpy will be 0 plus 0, that means 0. So here delta HF, enthalpy of formation of carbon dioxide, is equal to enthalpy of the reaction or heat of the reaction, that means delta H reaction, which is equal to, already we have seen, that is minus 400 kilojoule. Now, second problem. Calculate the enthalpy of formation of hydrogen chloride. So here also it is same. See, here also it is given delta H reaction, heat of the reaction, which is equal to product minus reactant. That means 2 moles of HCl is formed, 2 into delta HF formation of hydrogen chloride minus this delta HF formation of your hydrogen gas plus delta HF, that is formation of chlorine gas. Okay, this is 0, naturally occurring state. Formation of enthalpy of formation of the element is 0. So this is 0. So therefore, what we can write? We can write delta H reaction, which is equal to minus 44 kilocalorie, that is equal to 2 delta HF hydrogen chloride. So delta HF, that means enthalpy of formation of HCl, that will be equal to minus 44 by 2 is equal to minus 22 kilocalorie. Okay, so here everything, it is very simple. Here only it is given for 2 moles. Delta H reaction, enthalpy of reaction given for 2 moles. But But as per definition, enthalpy of formation for 1 mole. So just enthalpy of reaction divided by 2. Now, enthalpy of combustion. What is enthalpy of combustion? This is the amount of the heat released. Remember, in combustion, heat is always released. When 1 mole of the compound is burned completely in excess of oxygen. So here always heat is released. So therefore, always heat is released. So therefore, delta Hc is always negative. Okay. So delta Hc is always negative. Right. Now look at here. 2 moles of ethane is combusted with oxygen. Okay, this is combustion, and carbon dioxide, water is formed. Delta H reaction is minus 750 kilocalorie. So what will be delta H of combustion? What will be delta H of combustion? Delta H of combustion means just you have to calculate for 1 mole. It is given for 2 mole. Delta H combustion will be, that is equal to minus 750 by 2 is equal to minus 375 kilocalorie. Okay. Now, next is calorific value. What is calorific value? This is the amount of energy released from 1 gram of the fuel, not from 1 mole, 1 gram of the fuel. So we can write calorific value that is equal to, what we can write? Enthalpy of combustion delta Hc divided by molecular weight. Okay, and delta Hc, that is equal to, remember this thing, summation of the enthalpy of the reactant minus enthalpy of the product. Okay, and one more point, more calorific value means, what it is means? Means better fuel. Understood? Okay. Now let's see one problem. Identify the better fuel. What are the fuels? Methane and it is butane. Okay. That is, that enthalpy of combustion or heat of combustion value is given. Okay. So from here, what we can write? Methane molecular weight is 12 plus 4, 16. Okay. From 16 gram methane, energy released is equal to this 900 kilojoules. Okay. So from 1 gram methane, energy released will be how much? This 900 divided by 16. That means it is coming as 56.25 kilojoule. Okay. Now here, next one, butane. From, how much is the molecular weight of butane? That is 48 plus 10. That means 58. From 58 gram butane, energy released is equal to how much? 3000 kilojoules. Okay, 3000 kilojoules. So therefore from 1 gram butane, energy released will be your this 3000 divided by 58, and it is coming as 51.72 kilojoules. So where the energy released is more? From methane. Okay. Therefore, what we can write? Methane is better fuel. Better fuel. So, hope you have understood. Thank you.